One of the most popular techniques for reducing your time complexity is employing a hash map. But what is a hash map? A hash map is a data structure with key and value pairs similar to a map. And to get a value, you must know what the key is. And similar to a map, you cannot have any repeats for keys. As you can see in this visual, we have key and value pairs, and each key is assigned a value. These keys right here cannot have any repeats, but values can. However, what's different for a hash map is that these keys right here will be converted to hash codes through a hash function, and those hash codes will help determine where we can find the appropriate value. As you can see in this visual right here, we have key objects right here, in this case strings, and each of those strings will be converted to a hash code. For example, John Smith will be converted to 02, and that hash code will help determine the appropriate value in the hash map. A good hash function should be able to convert every possible key into a unique hash code and therefore a unique value. Constructing a hash map requires two types to be declared. For the first one, it's going to be the key object type, and for the second one, it's going to be the value object type. Now, in order to effectively use hash maps in our algorithms, we should definitely know the time complexity of hash map methods. For get, if we have a key, then we can just convert it to a hash code, which takes constant time. If we know the hash code, then we can use it as an index to find the appropriate value. So this time complexity is constant. What about get or default? Well, it's the same thing as get, but if we can't find anything, meaning that the hash code from this key has no value associated with it, then we just return default value. And just to clarify, the hash map does not change. This doesn't assign the default value to the hash code. So the time complexity is still 1. What about contains key? Well, same thing with get. All we do is convert key to a hash code and check if that hash code has a value with it. If it doesn't, we return false, and if it does, we return true. So same thing as get, its time complexity is constant. What about put? Well, put just inserts value, and same thing with the previous methods. It converts key to a hash code and uses that hash code as an index of a list and assigns a value to that hash code or index. So that would just be constant time. For the isEmpty method, it's a little bit tricky, but the time complexity is constant. To remove, same thing, all we do is convert the key to a hash code and then take the value from that hash code, which would be the index, and just remove it. So that time complexity is 1. For size, same thing with empty, it's always going to be constant time if the values are evenly spread. And you don't need to worry about that, just know that size and isEmpty are constant time complexity. What about for contains value? We don't have a key to convert it to a hash code, we only have a value, and that value may not be unique. So what we have to do is check through every single value, check through every single hash code that has a value, and check if that value is equal to this value. So its time complexity would therefore be the amount of elements in the hash map, so linear time.